Introduction.
Good to see you, Saba. When did you return from Egypt?
Only yesterday, Maisha.
I had been eagerly awaiting your return. Tell me all about the pyramids of Egypt, Saba.
Maisha, the pyramids are huge structures. They were built in 2500 BC. I have a photograph here for you.
Wow, they are simply beautiful. It shows that Egyptians, way back in 2500 BC, were great architects and builders.
That's true, Maisha. There is one more thing. Don't they remind you of the three-dimensional shape by the same name that we study in mathematics?
You are right, Saba. Now we will never forget the characteristics of pyramids. In this lesson, you will understand elementary shapes.
Objectives. At the end of this lesson, you'll be able to compare the lengths of line segments, identify right, straight, complete, acute, obtuse, and reflex angles, measure angles, classify triangles on the basis of angles and sides, categorize quadrilaterals, name polygons, identify 3D shapes. Comparison of line segments. A line segment is a section of a line that has two definite endpoints and hence can be measured. Line segments can be compared by observation, tracing, measurement. Let us look at each technique in detail. Comparison by observation. Look at the two line segments PQ and RS. Which one of the two line segments is shorter? Observe the two line segments. It is clear that PQ is shorter than RS. Comparison by tracing. Look at the two line segments MN and KL. Which one of the two line segments is longer? It is not clear from observation which one is longer. Therefore, trace KL on a tracing paper. Place it on MN. It is clear that KL is smaller than MN. Hence, MN is the longer line segment. Comparison by measurement. Look at the two line segments AB and CD. Which one of the two line segments is longer? Let us measure the two line segments with a ruler and decide which one is longer. On one side of the ruler, the measurements are written in inches and on the other side in centimeters. Let us use the centimeter side to measure the line segments. Place the ruler beneath AB such that one end of the ruler is right beneath A. Mark the length of AB. It is 5 centimeter. Repeat the process of CD. The length of CD is 3 centimeter. Therefore, AB is longer. Measurements can go wrong if the ruler is not placed right or if the person taking the measurement views it from a wrong angle. A better way to measure is to use the divider. Place the divider on AB such that the sharp end of one arm of the divider is on A and the sharp end of the other arm is on B. Measure AB. Place the divider on the ruler. Write down the measurement of AB as 5 centimeter. Now measure CD in the same way. Write down the measurement of CD as 3 centimeter. Therefore, AB is longer. Right, straight, and complete angles. There are 4 pockets A, B, C, and D in a residential locality. The 4 pockets are located like this. Rajiv lives in pocket A and is a fitness freak. Every day in the morning he jogs in and around the residential complex. Let us see the 2 different routes he takes. While jogging, Rajiv makes 3 different angles. They are right angle, straight angle, complete angle. Let us look at each angle in detail. Right angle. Let us look at the first route that Rajiv takes for jogging. He jogs from pocket A to pocket C, turns left, jogs to pocket D, turns left again, jogs to pocket B, turns left once more and jogs back to pocket A. Every time Rajiv turns left, he makes a right angle of 90 degrees. Thus, in one full round, he makes 4 right angles. Straight angle. Let us look at the second route that Rajiv takes for jogging. He jogs from pocket A to pocket C, turns left, jogs to pocket D, turns left again, jogs halfway towards pocket B, turns left once more, jogs to pocket A. When Rajiv jogs from pocket A to pocket C, he covers 2 right angles. In other words, he covers a straight angle of 180 degrees. Rajiv covers another straight angle in this jogging route. Can you identify it? Yes. When he jogs from pocket B to pocket A, he covers another straight angle. Complete angle. Let us take a second look at the first route that Rajiv takes for jogging. He jogs from pocket A to C to D to B and then back to A. In a single round, he covers 4 right angles. In other words, he covers a complete angle of 360 degrees. Acute, obtuse, and reflex angles. There are 3 more angles. They are acute angle, obtuse angle, reflex angle. Let us look at them one by one. Acute angle. Look at this picture of an open door. Can you identify the angle that it makes with the ground? Yes, 90 degrees. Now shut the door slowly. Can you identify the angle that it now makes with the ground? You're right, less than 90 degrees. Angles that measure less than 90 degrees are called acute angles. Obtuse angle. Let us go back to the picture of open door. What do you think will happen if you push the door further to the right? The measure of the angle will exceed 90 degrees. Angles that measure more than 90 degrees are called obtuse angle. Reflex angle. Look at this cake. 1/4 of it has been sliced out. A full cake makes a complete angle of 360 degrees. 1/4 of the cake sliced out forms 90 degrees. The cake that remains forms 270 degrees. Angles greater than 180 degrees are called reflex angles. Measurement of angles. Let us now learn to measure angles with a protractor. Protractor is a semicircular geometric instrument with markings from 0 to 180. These markings represent degrees. The outer markings are used to measure an angle whose vertex is formed on the left. The inner markings are used to measure an angle whose vertex is formed on the right. Measure angle AOB with the help of the protractor. Place the protractor on ray OB. Ensure that the horizontal line at the bottom of the protractor coincides with OB and its midpoint rests on vertex O. Check the inner marking that coincides with ray OA. It is 60. Therefore, the measure of angle AOB is 60 degrees. Measure angle MON with the help of the protractor. Place the protractor on ray OM. Ensure that the horizontal line at the bottom of the protractor coincides with ON and its midpoint rests on the vertex O. Check the outer marking that coincides with ray OM. It is 120. Therefore, the measure of angle MON is 120 degrees. Self-assessment. Match the angles with their measures. Classification of triangles. A triangle is a closed figure with three sides. We can classify all triangles on the basis of their sides, angles. Let us look at them one by one. Classification by sides. Triangles are classified on the basis of their sides into equilateral triangles, isosceles triangles, scalene triangles. Triangles in which all the three sides are equal are known as equilateral triangles. All the angles of equilateral triangles are also equal. Triangles in which two sides are equal are known as isosceles triangles. The angles opposite to the equal sides of isosceles triangles are also equal. Triangles in which all the sides are unequal are known as scalene triangles. All the angles of scalene triangles are unequal. Classification by angles. The sum of the angles of a triangle is 180 degree. Triangles are classified on the basis of their angles into acute-angled triangles, right-angled triangles, obtuse-angled triangles. Triangles in which all the three angles measure less than 90 degree are known as acute-angled triangles. Triangles in which any one angle measures exactly 90 degree are known as right-angled triangles. Triangles in which any one angle measures more than 90 degree are known as obtuse-angled triangles. Perpendicular lines. Look at these two lines. AB intersects CD. The point of intersection of the two lines is O. The four angles formed at the point of intersection are 90 degree each. Therefore, the two lines are said to be perpendicular to each other. If O is also the midpoint of CD, then AB bisects CD because it divides CD into two equal halves. Such a line which intersects another line at right angles and divides it into two equal halves is known as the perpendicular bisector of that line. Classification of quadrilaterals. Quadrilateral is a four-sided polygon. Quadrilaterals are classified as rectangle, square, parallelogram, rhombus, trapezium. Let us learn the properties of each. Rectangle. A rectangle is a quadrilateral whose opposite sides are equal and parallel, whose four angles are equal, whose each angle measures 90 degree, whose diagonals are equal and perpendicular to each other. Square. A square is a quadrilateral whose four sides are equal, opposite sides are parallel, four angles are equal, each angle measures 90 degree, diagonals are equal and perpendicular to each other. Parallelogram. A parallelogram is a quadrilateral whose opposite sides are equal and parallel, whose opposite angles are equal. Rhombus. A rhombus is a quadrilateral whose four sides are equal, opposite sides are parallel, opposite angles are equal, diagonals are perpendicular to each other. Trapezium. A trapezium is a quadrilateral whose opposite sides are parallel. Self-assessment. Let us know how much you have learned. Drag and drop the figures on their descriptions. Polygons. A polygon is a closed figure with 3 or more sides. Here are some polygons. Let us count their sides and name them. Three-dimensional shapes. Three-dimensional shapes have depth. They are not flat like two-dimensional shapes. Examples of three-dimensional shapes are cube, cone, sphere, cuboid, prism, pyramid, etc. The flat surfaces of a three-dimensional shape are known as its faces. The points where two faces meet are known as edges. The points where the edges meet are known as vertices. Let us look at the following three-dimensional shapes: cube and cuboid, triangular prism, square pyramid. Cube and cuboid. A cube, cuboid, has 6 faces, 12 edges, 8 vertices. An example of a cube is a dice. An example of a cuboid is a book. Triangular prism. A triangular prism has 2 triangular faces, 3 rectangular faces, 9 edges, 6 vertices. An example of a triangular prism is a tent. Square pyramid. A square pyramid has a square base, 1 square and 4 triangular faces, 8 edges, 5 vertices. An example of a square pyramid is the Egyptian pyramids. Summary. Let us summarize what we have learned. Angles are classified as acute, right, obtuse, straight, reflex, and complete angles. Triangles are classified as acute, obtuse, and right-angled on the basis of their angles. They are classified as equilateral, isosceles, and scalene on the basis of their sides. A quadrilateral is a 4-sided polygon. A polygon is a closed figure with 3 or more sides. Three-dimensional shapes have depth. A perpendicular bisector of a line intersects the line at right angles and divides it into 2 equal halves.